All right, so suppose you spin the spinner twice, find the probability of E and then a vowel. So this is compound. You're doing two different things. You're spinning it once and then spinning it again. So in the first spin, what's the probability of spinning an E? Well, there are 2 favorable outcomes out of a total of 6 possible outcomes. And then if you're looking at the probability of a vowel, how many vowels are there? We have 1, 2, 3, 4. So 4 favorable outcomes out of, again, 6 total possible outcomes. All right, and we're going to multiply those two together. I'm going to cross simplify here, or you could just reduce each fraction. Let's do that. So let's reduce here. 2 over 6 would reduce to 1/3, and 4 over 6 would reduce to 2/3. And that makes our multiplying a little bit easier. So 1 times 2 is 2, and 3 times 3 is 9. So 2/9 is the probability of spinning an E and then a vowel. Okay, for this one, write your answer as a fraction, a decimal, and a percent, so it wants all 3. You roll a standard number cube, find the probability of a number less than 6. So this is, in theory, what's the probability of a number less than 6? So we're going to put the number of outcomes, or favorable outcomes, over the total possible outcomes. So if you're talking about a standard cube, let's talk about the numbers that are on there. 1, 2, 3, 4, 5, 6. How many numbers are less than 6? Well, that would be 5 of them. So 5 favorable outcomes out of how many total possible outcomes? That would be 6 possible outcomes. So 5/6 would be the fraction that is in simplest form. Now let's write that as a decimal. So 5 divided by 6, that would give you 83 hundredths, and the 3 repeats forever and ever and ever and ever and ever. So put that line over it. And then what would that be as a percent? That would be 83%. All right, the Dairy Shack offers 3 flavors of ice cream: vanilla, chocolate, strawberry, and 4 toppings: fudge, sprinkles, cherry, almonds. Draw a tree diagram to show the combinations at Dairy Shack. All right, so remember, for a tree diagram, we're going to start with the first 3 things. So we have 3 flavors of ice cream here: vanilla, chocolate, and strawberry. So you're going to branch off in those 3 directions: vanilla, chocolate, and strawberry. And then for each flavor of ice cream, there are 4 different toppings. So for vanilla, we could have fudge, sprinkles, cherries, or almonds. So I need to branch out 4. 1, 2, 3, 4. So that's fudge, sprinkles, cherries, and almonds. I need to do the same here for chocolate and the same for strawberry. So 1, 2, 3, 4. 1, 2, 3, 4. So fudge, strawberries, cherries, almonds, fudge, strawberries, cherries, and almonds. So this tree diagram shows us how many total combinations there can be with 3 flavors of ice cream and 4 toppings. And as you can see, there are a total of 12. Donovan has a black hat, green hat, a white hat, and a red hat. For shoes, he can choose dress shoes or sandals. How many different outfits are in the sample space? So for this one, we can use fundamental counting. It didn't ask us to draw a tree diagram here. So how many options were there initially? Black hat, green hat, white hat, and red hat. So we had 4 options for hats, times how many options for shoes? 1, 2, because it's dress shoes or sandals, which means that there are a total of 8 outfits that he can create with the options that he has. All right, Fran spins the spinner twice. All of the sections of the spinner are equal sides. What's the probability that it will land on a 4 both times? So we're doing it twice. Let's talk about the first time she spins it. Well, there's 1 4 out of a total of 4 numbers. So 1 favorable outcome out of 4 possible outcomes. And then the second time she spins the spinner, they also want to know what's the chance it'll land on a 4. Again, that's 1 out of 4. So we would multiply. 1 times 1 is 1. 4 times 4 is 16. So the chance of her spinning a 4 and then a 4 again would be 1/16. Okay, what is the probability that the spinner will land on B? Spinner 1 will land on B, spinner 2 will land on a number less than 4, and spinner 3 will land on a green. And it says to write it as a fraction. So let's take a look at spinner 1. What's the chance that it will land on a B? Well, there is 1 favorable outcome there out of 2 possible outcomes for spinner 1. For spinner 2, what's the chance it will land on a number less than 4? Okay, how many numbers on spinner 2 are less than 4? 1, 2, 3. So 3 favorable outcomes out of 4 possible outcomes. And then for spinner 3, what's the chance it will land on a green? There's 1 favorable outcome out of 3 possible outcomes. So we will multiply these 3 together. So let's just multiply all of our numerators. 1 times 3 times 1 would give me 3 as my numerator. 2 times 4 is 8. And then 8 times 3 would give me 24. And this can be simplified. So 3, you can divide that by 3, and 24 divided by 3, which would give me 1/8. So the chance of getting a B, a number less than 4, and green would be 1/8. All right, so question 15 through 19, we're actually using the same spinners that we were just using for the previous question, but it's asking here about the likelihood of getting different things. So remember, when we're talking about likelihood, we're saying that it's certain, it's impossible, it's equally likely, it's less like, or it's unlikely, or it's likely. We're using that language to answer these questions. So let's take a look at the first one. It says, what is the likelihood of landing A on spinner 1? So if we look at spinner 1, there is 1 favorable outcome out of 2 possible outcomes, which is a half. Now, I like to write out the actual probability in a number first and then figure out what the word I would use. Well, since a half is 50%, then that means that we're equally likely to get an A here than a B. So equally likely. Okay. For 16, what is the likelihood of landing on yellow on spinner 3? Well, let's take a look at spinner 3. There is no yellow at all, right? So if I write it out as a number, the number of favorable outcomes is 0 out of how many total? 3. But that's just, it's not going to happen, right? You can't spin a 3 on spinner, you can't spin a yellow, I'm sorry, on spinner 3. So this is impossible. Okay, question number 17, what is the likelihood of landing on a number less than 4 on spinner 2? So how many favorable outcomes are there? 1, 2, 3. There are 3 numbers that are less than 4 out of 4 possible outcomes. 3/4 is 75%. So we would say that this is likely to happen because it is over a half. That is likely. What is the likelihood of landing on a color on spinner 3? Okay, well, for spinner 3, they're all colors, right? There are 3 favorable outcomes out of 3 possible outcomes. That's 100%. So this is certain. We are certain that we will land on a color on spinner 3. And then the last one, what is the likelihood of landing on 2 on spinner 2? So on spinner 2, we only have 1 favorable outcome, which would be a 2, out of 4 possible outcomes. So that would be 25%, which is unlikely because it's under 50. Right? Okay. The next question says 20% of women are left-handed. You design a simulation using playing cards to determine how many women would need to be selected at random before you found one that is left-handed. Red cards represent left-handed women and black cards represent all other women. Okay, so that remember when you're doing simulations, you want the simulation to represent the real situation that you're looking at. So let's keep in mind here that we said red cards are going to represent the left-handed women, and black cards are going to represent all other women, which would be the right-handed, okay? So also keep in mind it says 20% of women are left-handed. So we want to make sure that our simulation that we set up uses that 20% are left-handed. So the question reads, if you use 30 cards total, how many red cards would you need in your simulation? So essentially we need to find what is 20% of 30. Okay, they're saying we have 30 total cards and we want 20% of those cards to represent left-handed women. So 20% of them need to be red to represent left-handed women. So we can set up a proportion to figure out what is 20% of 30. Okay, when we cross multiply here, 20 times 30 would give me, I'm going to write it right here, 600. And then we need to divide by what's left. So divided by 100, which would give me 6. So that means in a deck of 30 total cards, we would need 6 of them to be red to represent our 20% of left-handed women. So our answer here would be, I'm going to switch colors, 6 red cards. All right, the next one says, if you use 14 red cards, then how many total cards would need to be in your simulation? So for this one, we're actually going to fill out the top as our 14, and we're going to figure out what the total would be if we still want to be using, that 14 still needs to represent 20% of the population. So we're still going to set up a proportion with the 14 representing the 20% and cross multiply to find the total amount of cards that we would have to use. So 14 times 100 would be 1400. Divide by what's left, that's 20, which would give us 70. So we would need 70 total cards if 14 of them were going to be red to make it represent 20% of the population, which would be left-handed. So 70 total cards. Okay, for this question, we are going to be using the tiles. It says Sasha has the following letters when she's playing Scrabble: A, K, N, N, E. It's saying she randomly picks out a letter, then without replacing it, picks out another. What is the probability she picks a K and then a vowel? So these are dependent events because she is not replacing the letter when she picks, after she picks the first letter. So first, let's look at the probability of her picking a K. That would be a 1 out of 5. And then what's the probability of her picking a vowel? Well, that K is gone now. And then we've got A and E as our vowels, so 2 out of 4. So we multiply that together. 1 times 2 is 2. 5 times 4 is 20. And then to simplify that, because we can divide both those by 2, we would get 1/10. So the chance of her getting a K, not replacing it, and then a vowel is 1/10. The next question says Sasha randomly picks out a letter, then without replacing it picks out another. What is the probability that she will pick an A and then an N or an E? So this is again dependent because she's not replacing that A. So let's look at her first event. The chance of her picking an A is still 1/5. There's only one A. But now that A is gone, and now it's saying what's the chance of her getting an N or an E. So there is 1, 2, 3 favorable outcomes out of 4 possible outcomes. Multiply, 1 times 3 we get 3, 5 times 4 we get 20. And that is simplified. So 3/20 is the chance of her getting an A, not replacing it, then selecting an N or an E. All right, please watch part 3 for the last couple questions.